Okay, so graphing logs is really, to be able to do this, the first thing you need to be able to do is graph an exponential function, because we know that logs are just inverses of exponentials. So if we have an exponential and we flip it around, we get a log function. So what that means is if we have y to the 2, y equals 2 to the x, then the inverse of that is going to be y equals log base 2 of x. So if we talk in terms of like a table of values on this thing, we have y, we've got, let's go -1, 0, and 1. So 2 to the -1 is half, and 2 to the 0 is 1, and 2 to the 1 is 2. So if we find the inverse of that, by just simply reversing our x and y, we're going to have half and -1, and 1 and 0, and 2 and 1. So let's go graph this. I'm going to graph my exponential in red here. So I'm going to go -1 and half and 0, 1 and 1 and 2. And it's going to do something like this. Okay, and I also know that my domain and range here, my domain is x is all real numbers, and x has to be greater than, or sorry, x is all real numbers, blah, and y is also all real numbers, but y has to be greater than 0. So let's look at the log. I'm going to graph the log in blue. So I'm going to go over half and down -1 and over 1 and up 0 and over 2 and up 1. So I'm going to get something that's going to do this. All right, and this is going to be what the graph of my log looks like. And on this, we know that this domain and range needs to reverse as well. So it makes sense that now my x is an element of all real numbers, and my x needs to be greater than 0. Which is what's happening here. See, like this is totally on the positive side. And it's doing exactly what we expect it to do. It's reflecting, you know, right over the line where it should be reflecting, like any good inverse does. Okay, so that's the basics of how the graph of a log function works. And then, of course, we can do transformations because, you know, we love transformations. So, God, that word's long. Okay, transformations. Let's see, we're going to make ourselves 4 columns here. 1, 2, 3, 4. So, up first, we've got vertical translations. And a vertical translation, you know, is f of x plus k. So in a log function, that's going to look like log of x plus k. And if we look at that, you know, like as an example, we would have something really simple. We would have like, I don't know, let's say log base 2 of x plus 3. And all that's going to do is it's going to shift our graph up 3. Okay, so let's go horizontal. If we have a horizontal translation, horizontal translations, of course, are f of x minus h. So on a log function, that's going to be log of x minus h. So as an example, we would have like the log base 2 of x, let's say minus 4. So the difference here is really these brackets. But see, in our vertical, you take the log base 2 of x and then you add 3 to it. So here, we're doing that to the x first. So what does that look like? This is horizontal, so it's going to do opposite math. So the opposite of minus 4 is plus 4. So this is going to move right 4. And if we're talking mapping notation, it's our x, right? It's our x that's going plus 4, and our y doesn't change. And the mapping notation here on vertical would be plus 3. Okay, let's keep going. Let's do a vertical stretch. So a vertical stretch is usually a times f of x. So in our log, it's just going to be a times, you know, the log of x. So that might look like 2 times log base 3 of x. And that's vertical, so vertical happens to our y's. So this is going to stretch by 2, which means we're going to have x comma 2y for mapping notation. And then we've of course got horizontal stretch, and horizontal stretch is normally f of bx, right? And then what that's going to look like for us is going to be log of, bx. So in this case, as an example, we might have like log base 3 of 2x. And that's going to do opposite math to our x. So that's going to it's going to cut everything in half because we always divide. So we're going to have x over b as our mapping notation. Okay, how about reflections? Reflections are also a thing. Let's do a vertical reflection. So a vertical reflection is usually just the negative of f of x. Well, just like everything else, we're just going to say the not negative log x. So this is going to look like, negative log base 5 of x. And that's going to give us, it's going to make it reflect, right? This reflects over x. It's vertical. And so we're going to, as per usual, have x and then a negative y. It's going to turn all of that upside down. And then we also have to have a horizontal reflection, which of course is f of negative x, which in our case is going to look like log of negative x. Now this gets tricky because we don't like negatives in our logs, so you're just going to have to, it's going to affect what values are there. So it might look like this. You might have log base, 3 of negative x. This is going to be a reflection over y, and it'll be negative x, y for your mapping notation. Okay, so what if we just look at a couple examples of this? So I think you've got 3 examples at the bottom of your page. Let's do the first one. Let's do some examples. We'll be quick. What if we have y equals the log base 2 of x minus 3? So now brackets matter here, right? Because these two things are not the same. These are not the same. So there are no brackets. And what that means is that we've got the log base 2 of x here, and then we're going to subtract 3 from it. Like that 3 is separate. Too bad I can't do this. Why? Okay. The 3 is separate. So let's talk about what this would look like if we were dealing with an exponential. So the inverse of this is 2 to the x, right? And 2 to the x would be, if we made a little table of values for 2 to the x, we would have 0, let's say 0 and 1. So 2 to the 0 is 1 and 2 to the 1 is 2. So then the log base 2 of x is going to reverse those, right? And then take it a step further. The log base 2 of x minus 3 means that we need to subtract 3 from all of our y's. So my x's aren't going to change, but my y's need to all go down by 3 because my mapping notation is going to be y minus 3. So 1 minus 3 is negative 2. So if you go and graph this, you're going to go to 1, negative 3, and 2, negative 2. So it's going to look like this. So all we've done is just drop it down a little bit. Make sense? Okay, let's do another example. Let's do y equals 5 times the log of x plus 2. So what's going on here? All right, so we've got this 5, so this is a vertical stretch, and then we also have this plus 2. It's in the bracket, so it's horizontal, and it's a translation. So mapping notation-wise, that means we're going to have x minus 2 and 5y. Now, this is a base of 10, right? This is a common log, so it's got a base of 10. So that means the exponential that this is coming from is 10 to the x. Well, let's make ourselves a little table of values on that. 10 to the negative 1 is a tenth, 10 to the 0 is 1, 10 to the 1 is 10. Reverse this for the log of x, and we have a tenth, and negative 1, and 1 and 0, and 10 and 1. Take that a step further with your transformations, right? Your x minus 2 and your 5y. And now we've got a tenth minus 2, which is, I don't know, something annoying. Let's negative 1.9, and then negative 5, because we're going to multiply by 5. And then 1 minus 2 is negative 1, and 0 times 5 is 0. And then 10 minus 2 is, 8, and 1 times 5 is 5. So when you're ready to graph this, you're going to say negative 2, negative 5. Well, it's not quite negative 2, but it's close. Negative 5. Negative 1, 0, and 8, 5. So it's going to look something like this. Okay. And then we can do a third example really quickly. Okay, our third example is going to be y equals the negative log of 3 of 2x minus 2. So now this one's got a lot going on here. So let's see, let's start with our mapping notation. We've got an x and a y. Well, first of all, we've got this negative, which is vertical. We've also got a 2 and a negative 2 here, which don't we need to rewrite this as minus 1? So that means we're going to take all of our x's and we're going to divide them by 2. And we're also going to add a plus 1 on this. Because we've got, so this is our vertical reflection. We have a horizontal stretch and a horizontal translation. So we had a base of 3 here. So the exponential on this is 3 to the x. So until we've really got this down, this is a good place to start. So 3 to the negative 1 is a third, and 3 to the 0 is 1, and 3 to the 1 is 3. Reverse to find your log. That gives you a third and negative 1, 1 and 0, and 3 and 1. Now add your mapping notation for your transformations. And we're going to have a third divided by 2, which is nothing pretty. The third divided by 2 is 0.116 plus 1 is 1.16. And then a negative y, so that's 1. And then a half plus 1 is 1.5, and a 0 again. And then 3 divided by 2 is, 1.5 plus 1 is 2.5, and a negative 1. So we're going to go graph this, and we'll be in business. So that means we're going to go a little past 1 and up to 1, and then we're going to go over to 1.5, 0, and then we're going to go over 2.5 and down 1, and we should end up with something that looks like this. Okay, That's all there is to it. No big deal. Okay, so I hope that made some sort of sense. Best of luck.